Let's go to page 79, and this is lesson 2.2, and this lesson is about analyze the conditional statements. Okay, so over here, a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. So again, a conditional statement has two parts, the hypothesis and conclusion. When a conditional statement is written in an if-then form, the if part contains a hypothesis, and the then part contains the conclusion. So here's an example. So it says, if it is raining, then there are clouds in the sky. So if part, the if is the part that is hypothesis. Then is a part that's conclusion. So if, then, so this is called if-then form. Okay? So again, this is the conditional statement. When you see the if-then, that means that this is a conditional statement, and the if part is the hypothesis. The then part is a conclusion. Okay, so be familiar with this format. Okay, now let's go to example 1. Okay, I'm going to keep this over here. Okay, example 1, write a statement in if-then form. Okay, rewrite the conditional statement in if-then form. All birds have feathers. Okay. So let's do the A first. So all birds have feathers. So you're going to write the statement in if-then, right? So the way to write is, so again, all birds have feathers, right? So the first part would be your if. So if an animal is a bird, then it has feathers. Okay. So that's your conditional statement, if, then. So the first part is your hypothesis. Second part is your conclusion. Okay, now let's look at the B. It says, two angles are supplementary if they are a linear pair. Okay, so you can bring it down. So they kind of. So notice you already have the if here already, right? So this is going to be. So pay attention to this. When they give you an if already, that is going to be your hypothesis. So this is your original sentence. Because the if is already, you want to move it to the front. Okay, so move this to the front. So it says if two angles are a linear pair, then they are supplementary. Okay, so again, if, then. So pay attention to where the if is. Okay, so if is your hypothesis, and the other part, then, that would be the conclusion. So that's how you write the statement. Okay, write the conditional statement. So again, if, then is called a conditional statement, and this is your standard way of writing it. Okay, now let's look at the bottom over here. Okay, the negation. Negation is like in algebra when you times by -1. Okay, negation is like that. Okay, so negation of the statement is the opposite of the original statement. Notice the statement 2 is already a negative, so its negative is positive. So you can think about if you have negative number, you times by negative, it becomes positive. Okay? So let's look at statement 1. It says the ball is red. So negation would be the ball is not red. See that? So you can see is, it becomes is not. So you can, in algebra, it's like times by -1. Okay? In geometry, when you're doing the statement, the negation, you just add the word not. Okay? Now, statement 2, the cat is not black. Now, it's already have a not. So when you put a negation, you get not become is. Okay? Okay, so you can think about opposite. So it's not, opposite become is. Okay? So again, negation means you do the opposite. Okay? In algebra, you just like times by -1. Okay, that's equivalent of that. Okay, now let's go to the next one. Okay, verifying statements. Conditional statement. Remember, conditional statements if then, right? Conditional statement can be true or false. To show that a conditional statement is true, you must prove that conclusion is true every time the hypothesis is true. To show that a conditional statement is false, you need to give only one counterexample. Okay? So again, to show the conditional statement is true, both the hypothesis and conditionality be true. To show it's false, all you have to do is show one counterexample. Okay. Now, okay, so let's go to the next paragraph. It says related conditional. Okay, to write the converse of a conditional statement, exchange the hypothesis and the conclusion. So converse is like a commutative. You switch the two. Okay, you switch the order of the two. So the hypothesis become conclusion. Conclusion become hypothesis. So you just switch the two parts. Okay. And it says to write the inverse of the conditional statement, okay, negate both the hypothesis and the conclusion. Okay, so before we have the negation, right? Negation would be just one part, whereas the inverse is a negation of both the hypothesis and the conclusion. Okay. So again, so the difference between inverse and negation is just one part, whereas the inverse is a negation of both parts, the hypothesis and the conclusion. Now, contrapositive, so you got to make sure you know all these vocabularies. Okay, contrapositive is when you do the converse and the inverse together. Okay, when you have the conditional statement, the if-then, you do the converse and then do the inverse. It doesn't matter which one you do first. You can do the inverse and the converse, or you do the converse and the inverse. It will become contrapositive. Now, the contrapositive is always equal to the original. Okay, so when you have original statement, when you do the converse and inverse, even though it looks different, but the result will be equal to the original. So let's look at an example. Okay, conditional statement. If measure angle A equal to 99 degrees, then angle A is obtuse. Okay, so that's your original. Now converse means you switch the two. Okay, so put this in the back, put this in the front. See that? So if angle A is obtuse, see that? So this go to the front and this go to the back. So that's what converse means. It means you switch the position. Okay, so if angle A is obtuse, then measure angle A is 99 degrees. So that's a converse of that. Okay, so here's your original. Okay, here's your original conditional statement. Converse is when you switch the two. Okay. Now let's go to the inverse. Okay, inverse means you make both negation without switching the order. Okay, so like over here, right? Originally you have measure angle A equal to 99, but now it says measure angle A not equal to 99 degrees. Okay, then over here originally then angle A is obtuse. Then over here it says then angle A is not obtuse. Okay, so again that's what inverse means. Inverse means you put negation on both the hypothesis and the conclusion. Okay. So now notice both these are false. Okay. Okay. Because this is false, because if it's obtuse, it does not have to equal to 99. It can be equal to 100. It can be 101. It can be any other one. So it does not have to equal to 99. Okay. So this is false. And this one, again, is false because if not equal to 99, then it's not obtuse. That's not true because what happens if it's equal to 100? See, if it's 100 degrees, it's still obtuse, right? Okay. So you have to be careful. A lot of time, not always. Okay. In many cases, okay, that the converse are false. Converse and inverse are false. Okay. Now, things you have to watch out for is that the converse and inverse are not equal to the original. Okay. Then, in some rare cases, they can equal, but almost most of the time they are not equal. Okay, because the converse and inverse are not equal to the original. Okay. Now let's go to contrapositive. Contrapositive means you do both the converse and the inverse. Okay, you switch and you make the negation. Okay, and these, okay, the contrapositives are equal to the original. Okay, original and contrapositive are equal. They are equivalent. Okay, so again, first you switch the two, right? So the obtuse and the 99, right? Then you have to put negation. Okay, so if angle A is not obtuse, then measure of angle A is not equal to 99 degrees. Okay. Okay, so again, so this is true. Okay. Okay. So now let's go to example 2. It says write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement. Guitar players are musicians. Decide whether each statement is true or false. Solution. Okay, if then. So let's start with the original, right? So it says, if you are a guitar player, right? So that's your first part, and that's your second part, right? Then you are a musician. So that's your original. Write the statement in the if-then form. Okay, so this is your conditional statement, right? This is your conditional statement. Now, converse is switch the two, right? Remember, converse is switch the two. So if you are, say, the musician go to the front and the guitar player goes to the back, right? So converse is if you are a musician, then you are a guitar player, okay? And this is false because not all musicians play guitar, right? Because some musicians play piano, some musicians play different instruments, right? So again, this is false, okay? Okay, now let's go to the inverse. Okay, inverse is you don't switch the position, you just make a negation, okay? So over here, if you are a guitar player, inverse will be if you are not a guitar player, right? Over here, the original is you are a musician, so the inverse would be then you are not a musician, okay? So make sure you don't get confused between the two, okay? And again, this is false, right? It says even if you don't play a guitar, right? Even if you don't play guitar, you still can be a musician. Okay, now here's a contrapositive. Remember, contrapositive, you switch the position and put a negation, right? So now the musician go to the front and become not, right? So that over here, if you are not a musician, then you are not a guitar player, okay? So that's true, okay? A person who is not a musician cannot be a guitar player, okay? So make sure you understand the difference between all this four, right? Original conditional statement, the converse means to switch the position, the if, the first part and the second part. Switch the hypothesis and the conclusion. Inverse means you apply the negation to the hypothesis and the conclusion. Contrapositive is you do both, converse and inverse, okay? Usually easier to do the converse than do the inverse, okay, when you're going to do the contrapositive. Okay. And again, contrapositive is equivalent or equal to the conditional statement, the original. Okay, so the conditional and contrapositive are equal. Okay, they're equivalent, but not the converse and inverse. Okay, so just be aware of that. Okay, so we have the statement down here. The equivalent statements. A conditional statement and its contrapositive are either both true or both false. Similarly, the converse and inverse of the conditional statements are either both true or both false. Okay, pairs of the statements such as these are called equivalent statements. In general, when two statements are both true or both false, they are called equivalent statements. Okay, let's go to page 81. Okay, so definition. Okay, so you can write a definition as a conditional statement in if-then form or as its converse. Both conditional statement and its converse are true. For example, consider the definition perpendicular line. So sometimes you can write the definition in the if-then form. Okay, so keep this in your notebook. Key concept: perpendicular lines. So this is one of the factors you need to know. Okay, definition: if two lines intersect to form a right angle, so if two lines intersect to form a right angle, then they are perpendicular lines. It says the definition can also written using the converse. If two lines are perpendicular, then they intersect to form a right angle. Okay, you can write the line L, the cursive L, is perpendicular to line M as L perpendicular line. So this is the upside down capital T. That is a symbol for perpendicular. Okay, let's go to example 3. Use definitions. Decide whether each statement about the diagram is true. So here's your diagram. Explain your answer using the definition you have learned. Okay, so over here, you have a line AC. So here's your line AC is perpendicular to line BD. Okay, so is this true Is this true or false? The answer is true because of this little symbol right here that tells you that these are right angle, therefore these are perpendicular. Okay. So here let's go to the solution. So this statement is true. The right angle symbol in the diagram indicate that the lines intersect to form a right angle. So you can say that the lines are perpendicular. Okay. Now let's look at B. It says angle AEB, so AEB is this angle right over here, and CEB, so you're talking about AEB, so that this angle, and CEB, this angle. So we're talking about these two angles, okay, are a linear pair, okay? And again, this is true because, remember this, because they have a, the two of their sides form a straight line, right? So they are linear pairs, okay? So B, it says this statement is true by definition if the non-common sides of adjacent angles are opposite rays, see the opposite rays, then the angles are a linear pair because EA, the ray EA, and the ray EC are opposite rays. So therefore, angle AEB and angle, so AEB and CEB are linear pair. Okay. Now let's look at C. It says EA, so that's EA, and EB are opposite ray. Well, this is false, right? You can see it obviously, right? EA and EB are not straight line. Okay. Okay. So it says. Okay. So it says this statement is false. Okay. Point E does not lie on the same line as A and B. Okay. So the rays are not opposite ray. Okay. So again, the point E does not lie on the same line. Okay. So see, you have this line, you have this line. So they are not on the same line. So they are not a linear pair. They have to be on one single, one same line. Okay. Okay. Okay, let's go to page 82. Biconditional. Biconditional statements. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. Okay, it says a biconditional statement is a statement that contains a phrase "if and only if," and any valid definition can be written as biconditional statement. What it's saying is, think about the street. Okay, conditional statement is if then, right? That is like one-way street. Okay. So when you go down, so one-way street, you only can go down one direction. Okay, if you go opposite direction, you may get into accident, for example. So conditional statement, if you go backward, it's like a converse, right? If you switch the if and then, right? If you switch, it may become false. Okay. Whereas biconditional statement means it's almost like a two-way street. Okay, you can go this way, you can go this way. Okay, and each one stay on its own side. There will be no problem. Okay, so think of what, see, the bi means two, right? So biconditional statement, think of it as like the street is two direction. Okay, so you can go to the right, you can go to the left without any problems. Okay, and the way to write is if and only if, and abbreviation of that is IFF. So if then is just IF, right? If and only if you write IFF with I and F and F, so two F's. Okay, so when you see IFF, that means if and only if. That means that's a biconditional. Okay? So biconditional means it's like a two-way street. So you can either go forward or backward. Both would be true. Okay, so you can switch the if, then switch the hypothesis and the conclusion without any problem. Okay, but that's only if it's biconditional. Okay, if it's not biconditional, if it's regular conditional, when you switch, it becomes converse, and the converse may sometimes it is false. Okay, so you have to be careful with that. So if you can switch, then that's biconditional. Okay, for biconditional, your converse is also true. Okay, because it's two-way street, right? You can switch with no problem. Okay. Okay, so let's go to example 4. Okay, write the definition of a perpendicular line as a biconditional. So definition: if two lines intersect to form a right angle, then they are perpendicular. So converse, it says if two lines are perpendicular, you switch, right? Then they form a right angle. Okay. Now because the original and the converse, so if you go one way, no problem. Come back the opposite direction, no problem. That means this is like two-way street. Okay. Because if the converse is false, that means it's going the wrong direction on a one-way street and you run into accident. Okay. And so if it's not biconditional, when you make the converse can become false. Okay, so be aware of that. So if both are true, so if you can switch without any problem, if the converse is true and the original is also true, that means you can go both directions. That means it's biconditional. Okay, again, biconditional means you can go both ways. Okay, and both are still okay. Now, if it's not okay, then it's not biconditional. Okay, so anyway, so here's your converse. So because both are true, then we can make it into biconditional. It says if two lines, it says two, so instead of write if then, right? Notice you got if and only if. So two lines, so notice you don't use if and then anymore because it doesn't matter, because this one you only can, this is the if part is your hypothesis, then part is your conclusion. But since you can go either way, so you don't need an if then, right? So you write if and only if. That means it doesn't matter which part goes first. Okay, you can switch. Okay, and that's the reason for that. Okay, so it says two lines are perpendicular if and only if they intersect to form a right angle. Another way, you also can move this to the front, right? You can say, two lines intersect to form a right angle if and only if they are perpendicular, right? So just again, biconditional means you can switch, okay, and it was still true, okay. Now, if we cannot do that, then it's not biconditional. Okay, it would be just regular conditional statement.